Hi and Assalamualaikum to our beloved Madam Farah. So today our group would like to present a title, High Performance Liquid Chromatography. So this is our team members. The first one is me, Nur Alia Balkis binti Syamsuddin, and the second one is Nur Shazwana Husna binti Muhammad Nazri. The third one is Nur Ayuni Izzati binti Rozmi, and the last one is Naili binti Muhammad Nazari. I would like to explain the introduction of HPLC. What is HPLC? HPLC stands for High Performance Liquid Chromatography, which is a technique that uses a liquid mobile phase to separate components in a mixture. The sample is dissolved in a solvent and passed through a column under high pressure. HPLC is highly versatile and can separate a wide range of chemical mixture, including organic, inorganic, and biological samples. Also synthetic or natural polymers and compounds that are unstable at high temperature. Next, moving on to our objective. The first one is to determine the retention time of a standard solution. The second one is to identify the caffeine peak in a soft drink sample. The third one is to determine the amount of caffeine in soft drink sample using the response factor method. Let's go through how HPLC works step by step. The process begins with a mobile phase reservoir which holds pure solvents. These solvents dissolve the sample components and must be chemically compatible with the method. Next, the pump drives the mobile phase through the system at a steady flow to ensure consistent pressure and avoiding pulsation. This is crucial for reliable analysis. Next, the injector introduces the sample into the mobile phase. This precise addition to ensure that the sample is properly mixed and delivered into the system for accurate results. After injection, the sample enters the guide column, which traps impurities to protect the main analytical column. The analytical column, packed with a stationary phase, is where the actual separation of sample components happen, giving a high-resolution analysis. The separated components then move to the detector, which identifies and measures them based on their concentration in the mobile phase. Finally, the data system records, processes, and interprets the information, presenting a clear result for analysis.
Moving on to the result and calculation for the concentration in this experiment. This result displays the graph for determination of caffeine in standard caffeine. The highest peak at 2.482 shown, determined as the caffeine peak to make a comparison between other two samples, which is Coke and Levita. Next, the graph for determination of caffeine in Coke. It shows variable of peak, but only one peak will be determined as caffeine peak, which is at 2.481. And lastly, the graph for determination of caffeine in Levita. The caffeine peak indicated at 2.479. From the table shown, this is the analysis from the result determined by high-performance liquid chromatography. It provides useful information on retention time and peak area of all caffeine in all samples. This proves that the objective is successfully achieved. The caffeine standards exhibited rotation time of 2.482 in minutes, and the peak area of caffeine is 6,249.48779, and this result can be used as a reference to identify Coke and Levita sample. As for Coke, it shows higher peak area at 7,001.12305 and retention time at 2.481 in minutes, shows nearly identical as standard caffeine. This proof that the existence of caffeine in the soft drink is obtainable, while Levita display a retention time of 2.479 in minutes with higher peak area at 11,151.10000 compared to the standard, and indicates that Levita contain more caffeine than both standard and Coke sample. Next slide is about calculation on concentration of caffeine in ppm in Coke and Levita sample. First of all, the RF value of the standard caffeine had obtained by divided the peak area caffeine standard with the concentration of caffeine standard. Based on the equation given, the RF for the standard caffeine is 62,494.8779 milligrams per milliliter. After that, the concentration of caffeine in Coke sample is determined by the peak area caffeine standard, which is 7001.12305 divided to RF value obtained before, which is 62,494.8779, and convert to unit ppm. The final value is 112.03 ppm. The formula to obtain the value on the concentration of caffeine in Levita is the same, and the final calculation is 178.432 ppm.
First, I will briefly explain details about HPLC before going into discussion. High-performance liquid chromatography (HPLC) is a technique in analytical chemistry used to separate the components in a mixture and to identify and quantify each component. It was initially discovered as an analytical technique in the early 20th century and was first used to separate colored compounds. The most important aspect of HPLC is the high separation capacity, which enables the batch analysis of multiple components. Even if the sample consists of a mixture, HPLC will allow the target components to be separated, detected, and quantified. Also, under appropriate condition, it is possible to attain a high level of reproducibility with a coefficient of variation not exceeding 1%. Also, it has a high sensitivity while a low sample consumption. HPLC has one advantage over GC column, that analysis is possible for any sample can be stably dissolved in the eluent and need not to be vaporized. With this reason, HPLC is used much more frequently in the field of biochemistry and pharmaceutical than the GC column. Moving on to discussion, in HPLC, each component elutes from the column as peak on the recorder. Chromatogram is the response of detector to each component displayed. Reverse phase HPLC is more widely used due to its versatility and better reproducibility. It is also used in this experiment as caffeine is a moderately polar compound that interacts well with the non-polar stationary phase, while gradient elution is used for a better separation as it ensures caffeine is well resolved from other substances, improve sensitivity by reduces background noise from interfering compounds, and gives faster analysis as it shortens runtime compared to isocratic elution, where all compounds elute at a constant solvent composition. There are three chromatograms discussed in this experiment, which are caffeine, Coke, and Levita. The retention time of standard caffeine is 2.482 minutes, which it only took 2.482 minutes to travel from the injection point to the detector through the column. The retention time for Coke is 2.481 minutes, and the concentration of caffeine in Coke is 112.03 ppm, while the retention time for Levita is 2.479 minutes, and concentration of caffeine in Levita is 178.43 ppm. From this, we can determine that Levita has a higher caffeine content than Coke. The presence of caffeine is confirmed when the value of retention time of chromatogram, both sample is almost close to retention time in standard caffeine. Coke eluted slower as it takes a longer retention time that gives a shorter peak, while Levita eluted faster as it takes shorter time that gives longer peak of caffeine.
In conclusion, the experiment confirmed the presence of caffeine in Coke and Levita using reverse phase HPLC with retention times matching the standard caffeine. Levita had a higher caffeine content 178.43 ppm than Coke 112.03 ppm. Gradient illusion improved separation and analysis speed, making this method effective for caffeine quantification. In addition, we have fully achieved our objective with these findings.